and we're going to warm up our math brains. Today, you will find the lesson in your Google Classroom under Math. Today is actually lesson 313. It looks like. I didn't change that, so I'm going to change that right there. 3.13. All right, so our learning target today is still looking at graphing, but we're actually going to use frequency tables and line plots today. And that's so we can solve real-world math problems that involve frequency tables and line plots. And our success criteria is to analyze frequency tables and line plots. That means kind of look at them closely, look at the data, see what we can learn from them. And then we're going to actually make our own line plot using a set of data that includes fractions, hence the ruler, and measuring. So we're kind of mixing some of our skills today, which I love when we get to do that. But before we get started on our learning target, first we want to review. And this review is going to help you when you come in on Thursday for that map test. Our first 4 problems are multiplication and division. So we have 8 times 8. 8 times 8. Now, yesterday I talked about if you come across a problem that you do not know, like, I don't know my 8s, Mrs. Alban, Mrs. Harrison, what am I going to do? You can always draw a picture. Now, that sounds hard for 8 times 8, and it would be time consuming, but it's better than not trying at all. I think there's an easier way of doing it that you might know, but if it's something you struggle with, you may go back to a picture. And I'm just going to show you what I mean. If I know 8 groups of 8 is that multiplication problem, I can draw 8 circles. And again, I know it's a lot. 1, 2, 3, 4, 5, 6, 7, 8. And I can draw my 8 tally marks or dots, whatever you want to do. That's easy for you to count to help you. There's no shame in this, because the more you do it, the less you'll have to do it, because you will memorize it. But you're not going to want to do this every time. But it is a strategy that, oopsie, you don't want that one, that will give you the answer. So now that I drew 8 groups of 8, game, how can I find out what 8 times 8 is from my picture? What could I do?
So you could count all of them by themselves, or you could count by 8.
I could count by 8s, or you're right, I could just count the tally marks. It depends on where you're at. Counting by 8s is difficult. So I just count all the tally marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. Holy moly, that was a lot of counting. Is there a shorter way to figure out 8 times 8?
Yes.
Okay, Haley, what do we do?
So you can do 9 times 8, which all you have to do is put down your 8th finger and you get 72, but then you have to take away 8, and then if you take away 8, it'll be the same answer as 8 times 8.
So excellent strategy. If you know 9 eighths is 72, then you could subtract 8 and get 64. That's a great one. You could also, if you know 5 times 8 equals 40, and you need 3 more 8s, you could add 3 more 8s to 40, and that would also give you 64. All right, so 7 times 8. 7 times 8. I already know 8 times 8 is 64. How could I use that to help me find 7 times 8?
Just take away one of the 8s from 64.
All right, I'm going to look for hands so that everyone gets a chance, okay? So I know a lot of you like to just say your thinking, and I appreciate that you have thinking to share, but we want to make sure everyone gets a turn. Sunny Poe, can you tell us what you're thinking? How can I solve that?
So what I was thinking, it said, because we just did the problem 8 times 8, you could just take away 8 from 64, which equals 56.
I love your thinking. So if we know 8 times 8 is 64, let's subtract 8 and get 56. Boop. 7 times 8 is 56. All right, 36 divided by 9. Does anyone know how to use the nines trick for division? Astria, how can I use the nines trick for division?
How you use the 9 tricks for division is, since it's 3, you just put down your 4th finger, and then it should be 36.
So you make 36 with your fingers, 3 fingers for your 10s, 6 fingers for your 1s. That means your 4th finger has to go down. So 36 divided by 9 must equal
4.
Now, if you're not sure, again, with division, you can do the same thing. I can draw 9 circles, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I can divide 36 evenly into these circles. Watch how I do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. I'm stopping at 36 because that is the dividend, right? Now I can find my quotient or my answer to my division problem by seeing how many tally marks are in each circle. Not all together, that was multiplication. But I count 1, 2, 3, 4. That's the answer, right? So you can see how many are in each circle when you're dividing. That's just, if you can't use the other strategies, if you get confused and you're like, I don't remember all the strategies Mrs. Hubben has taught me, go back to drawing a picture. It's definitely gonna help you. All right, 16 divided by 4. Reese, how can I figure out how many 4s are in 16?
Count by 4s until you get to 16.
Can you do that for me? Can you unmute and count by 4s?
4, 8.
What would 4 more than 8 be?
8, 12, 4, 16.
All right, so how many is that?
4.
Excellent. We also can use the inverse operation. If we want to know what 16 divided by 4 equals, we can use 4 times what equals 16? 4 times 4, right? Nicely done. All right, we're going to look at this problem. I would like you guys to be writing these in your math spiral. And here's why. Not because I'm a mean teacher and she makes us work, do all this hard work. Well, the reason I want you to do this is because when you practice it, if you watch me do it, that's silly. I'm 51 years old. I've been doing math for a long time. I know how to do this. You guys need the practice, right? So if you were in class, I'd have you doing it in your math spiral or holding it up on your whiteboards. Same thing, just because you're at home, I still want you to be writing this in your math spiral. So this is what I'm gonna ask. I'm gonna ask you to hold it up for Mrs. Harrison when you're done. Write the problem 576 plus 138. When you write it, line up those digits. So this is not me doing the work. This is you doing the work with guidance, right? Thank you, Lennox, for following directions. That makes me really proud of you. You don't learn by watching me. You learn by doing. So go ahead and let's start with Max Diesberg. How can I solve that problem? And you guys do this with me.
All right, thank you. Remember, you're supposed to be showing me. Thank you, Miss Astria.
So first you add 6 plus 8, which would be 14. And then you put the 1 by the 8. Then 1 plus 8 plus 4 is 13. So you put the 1 above the 7.
Max,
Then-
I think we're on a different problem. I'm on 576 plus 138. And you said 6 plus 8 is 14, and we made that new 10. But now I have 1 plus 7 plus 3. I think you
And then
were another one.
1 plus 7 plus 3 is 11. And then you put the 1 above the 5. Then 1 plus 5 plus 1 is 7.
Excellent. 714. Okay, we're going to do the next one. Everybody's going to write it in their spiral. Thank you, Josh. Thank you guys for taking ownership of your learning.
I did have
Sunny.
several. Thank you. I didn't have everybody, but I did have several.
Thank you very much. You're going to pay, it's going to pay off for you because you're learning more when you do it. 785 plus 647. Remember, when you write these problems, line up your place values.
My friend Haley Booker would love to be your guider of the answer.
Let's do it. Walk me through it, Haley Booker.
So first you do 5 plus 7, and that equals 13.
Okay, try again. Stop. I'm going to stop you. 5 plus 7. Say 7 in your head. Maybe count up 5 more. 7, 8, 9, 10, 11, 12.
12.
There you
And
go.
then you put the 2 underneath the 7, and you put the 1 above the 8. And then you do 1 plus 8 plus 4, and that equals 12. And then you put
Wait, I'm going to stop you again. Let's count. If you have 1 plus 8, what's that going to equal?
it equals 13.
Is 1 plus 8 is 9. 4 more, 10, 11, 12, 13. Don't forget to add this 1 in, right? That's important.
Uh-huh.
Okay, go ahead.
And then you do 1 plus 7 plus 6, and that equals 13.
Okay, but what are you forgetting to add?
The
Because-
1.
Yeah, because 6 plus 7 would be 13, but we have to add the 1 that we made the new group of. So what would that be now?
14.
There you go.
1, you put the 4, and then you put your comma, and that
Can you
equals
keep that number for us?
1,432.
Excellent. Okay, I'm going to do the next one for time's sake, but I want you to do it with me. We're going to look at 2 minus 8. Because 2 is less than 8, I cannot subtract 8 from 2. I have to make a new group of 10, ungroup this 10 here, make it 2 groups of 10. Now I've got 12. 12 minus 8. I'm going to count up, 8 in my head, 9, 10, 11, 12. I get 4. 2 minus 6, I can't do. I'm going to make a new group of 10 there so I can do it because 2 is less than 6, so that won't work. If the number on top is less than the number you're subtracting, you have to get a new group of 10. You have to do it. 12 minus 6, double stack backwards, is 6. And 8 minus 4 should be 4. All right, 700 minus 378. All right, Charlie Carr, I see your hand is up.
So I can't do 8 from 0, and I can't cross out a 0, so I have to go. So what I do is I box up the 70, cross it out, make it a 69, and then bring the 1 over to the 0, and 10 minus 8 is 2, and 9 minus 7 is 3.
Let's count 7, 8, 9. 9 minus 7 is 2, right? There's a,
2.
because 7 plus 2 equals 9.
And 4 minus 3 is 1.
Oh, okay, wait, go back to the problem. It's a 6. 6 minus 3.
And 6 minus 3 is 3.
Much better. All right. Looking at the clock.
I do have a friend who is willing to help you out. It's Haley Calendar.
Okay, Haley, go for it. What time is it?
I think it is 101.
I agree with your hour, but I disagree with your minutes. Because from here to here is 5, and then you have 1 minute here. How many minutes have passed the 1 o'clock hour? 5 plus 1, what should it be?
106.
Very good. If it's 1:06 and I am at school, is it AM or PM?
PM.
Very good. If it's 1:06 and I'm sleeping, is it AM or PM?
AM.
Nice. All right, next one. Next clock. How about Lennox? What time is it, Lennox?
There, me. Hey, grandfather, do you want to know what there means? Another thing for.
Charlie Carr, I think you need to mute so Lennox can share. Thank you.
Trying to get there.
The next one is 3:30.
Very good. 3:30. How did you know?
Because I always know that the 6 is in half of the clock, so that's 30. And I know that the shorthand is at this almost sorta at the 3.
Nice job. Halfway between the 3 and the 4. So you always go to the number earlier, right? The number that it's still within that hour. All right. What unit is better to measure a plastic spoon? And I apologize for that capital. Sometimes that should be lowercase. Ounces or pounds? Write it in your spiral. Ounces or pounds? And I'm going to give you a benchmark. An ounce weighs about the same as like 10 pennies here. A pound weighs about a heavy book like this. So would you use ounces or pounds? Thinking about your benchmarks. Josh Carter,
Ounces.
why do you think ounces? You're right.
Because if you use pounds, then if it was like 5 pounds, then it would be a heavy spoon.
That'd be a real heavy spoon. I don't think we could eat with it. Thank you. Yeah, if we were going to measure the weight of Josh, we would use pounds, but not the weight of a plastic spoon. Good job. If you participated, and what I mean by participated, if you wrote the answers in your spiral right now, I want you to give yourself a pat on the back. I'm really proud of you. That's from Mrs. Harrison and I. I appreciate that. It makes me happy that you're engaging and taking responsibility for your learning. So good job. All right. So now let's talk about tally charts because we're going to use them. Here's a real quick video to get your brain thinking.
Where should we go on our next class trip? The zoo, the firehouse, or the apple orchard? I'm taking a survey and making a tally chart. What are surveys and tally charts? A survey is a list of questions used to collect information or opinions. Let's see. There are 3 dinosaurs here. Let's take a survey to find out which one our classmates like best. We can use a tally chart to record data or information. Let's see. Louie likes the Stegosaurus the best. You can draw 1 tally mark to stand for 1 vote. 5 kids like the Triceratops. So I'll draw 5 tally marks in that row. 1, 2, 3, 4. The 5th mark is drawn across the other 4. Well, when you group the tally marks by 5, you can count by 5. 5, 10, 15, 20. Sets of 5s are easier to count. 7 kids like the T-Rex. So after I draw 5 tally marks, I can add 2 more to make 7. Oh, right. I forgot to vote. My favorite dinosaur is the Triceratops. I'll add a tally mark to that row. It's really easy to add to tally charts. Now I can count the votes and use the tally chart to make a bar graph.
Okay. Oopsie, sorry. Okay, so next. So let's turn to page 203. And we're going to analyze tally charts, frequency tables, and line plots before we make our own. And Mrs. Harrison's going to help me with that part. But first, I want to really look at these so we understand what they do and how we use that information. So in your math workbook, you'll find page 203 has examples of all 3. A tally chart, a frequency table, and a line plot. So just like the video showed us, a tally chart uses tally marks to give data, to give that information. So the ages of some players on a basketball team can be shown in different ways. So somebody took a survey and said, hey, I want to know the ages of the players on this basketball team. So they went and asked all the players what their age was, and this is what they found. 7 got 1 tally mark. 8, the age of 8 got 3, 9 got 5, 10 got 4, and 11 got 2. Now in a frequency table, it's very similar to a tally chart, but there's something different. Henry, what do you notice that's different between the tally chart and the frequency table? They're super similar, but there's something different. What is it?
that they have different numbers and tallies.
Okay, so on a tally chart, you actually have tally marks to represent the number of players that are that age. But in the frequency table, look, now instead of tally marks, what do we see, Henry? What are these?
Numbers.
They're numbers now. So a frequency table just changes the tally marks to numbers. So you could use either one of these to help you create your line plot. Now a line plot is a type of graph, really, and it's showing you the ages of the basketball players. That's kind of like your title, but it's down below. You have 7, 8, 9, 10, 11. Each dot represents one vote or one player in this case. Unlike a pictograph, a line plot does not have a key. It does not equal 3 players or 2. Line plots, it only equals 1. So this equals 1. This one dot. So only one player is 7 years old. So that's a little different than a pictograph. All right, let's look at the data and answer some questions. At the bottom of page 203, the first question is, how many basketball players are 10 years old? Look at the line plot or look at the frequency table or the tally chart and see if you can answer that question. How many basketball players are 10 years old? Lila Fitz, what do you think?
4
Excellent. Where did you get your information?
from the tally chart.
Okay, so if you use the tally chart, you had to look at what number?
The 10 to get the answer.
And you counted your tallies and got 4. Okay, nicely done. All right, which age appears the most often? Go ahead and write your answer. Which age do you see the most often? Reese, I see you've raised your hand.
9 the most often.
How do you know? You're right. How do you know that?
Because I counted the dots in the line plot.
Okay, so we've got 1, 2, 3, 4, 5. Is 5 the most out of all of these ages? Yes.
Yes.
So we would say 9, age 9. All right, are there more players younger than 9 or more players that are older than 9? Think about that. Use the line plot. I would go with the line plot to answer that question.
I don't get that question.
Okay, so let's dissect it, analyze it. You have to look at 9, right? I think that was Haley. You have to look at the age of 9. And it's asking you, are there more players that are younger than 9? So think about what's younger than 9, Haley. What ages are younger than 9?
1, 2, 3, 4, 5, 6, 7, 8.
But we don't see those on our line plot. What do we see on our line plot that they surveyed? Which ages?
7 and 8.
Okay, so how many votes does 7 and 8 have? Or players?
4.
4, okay. So we know there are 4 players that are younger than 9. Now I have to look and see how many players are older than 9. What ages were older than 9 on our line plot?
10 and 11.
Right. How many players are ages 10 and 11? What are you going to do? You got to count them up, Haley. What did you get?
I got 6.
Okay, so now can you answer the question? Are there more players younger than 9 or more players that are older than 9? Why don't you stand up if you think there are more players younger than 9? Stand up if you think there are more players younger than 9. Stand up if you think there are more players older than 9. You got to stand up for one of them. Thank you, Gavin. Thank you, Henrik. Thank you, Robert. Otherwise, I think you don't know what we're talking about. So this is your participation time, and you can move a little. All right, Lennox, you should be standing because 6 is more than 4, right? 6 is greater than 4. So to answer that question, you would say there are more players older than 9. Go ahead and write that in now. And I'm going to write it over here because my board won't let me go low. There are more players older than 9. Okay? Now you get a chance to write another question that can be answered by using the line plot or the frequency table or the tally chart. Anybody have an idea? How about Cooper? What is a question you could ask your peers that they would have to use that data to answer?
How many players are 10?
Excellent. Go ahead and write that in your book. Make sure you have a capital at the beginning of your sentence and a question mark at the end. Cooper, can you write that for me? If you haven't already, okay. August, what's another question? And Cooper, whole body listening. That's very distracting. Thank you. August, can you think of a question we could ask? No. Well, let's start with how many. What are we talking about? Go ahead and say how many. Can you say players?
Children. Players.
What do you want to know? Do you want to know a certain age or do you want to know?
For the age.
So Cooper said how many players are 10 years old? What's another age you could ask about?
How many players are 9?
Excellent. That would be a good question. Josh Carter, I see you have your hand up. Go ahead, Josh.
How many players in all?
How many players are on the team? I like that. Could you combine a couple?
I
What
was gonna, Miss Alvin, I was gonna ask how many players are playing all together.
That's, yeah, what Josh said. Ben, what do you think? Could we say how many players are 7 and 8? Would that work?
Yeah.
Ben?
Yes.
Yeah, what was your question, Ben?
Are there more players? Are there more players that are 10 or 9?
Okay, excellent. All right, so we are going to move on to creating line plots with fractions. So you're going to need your ruler for this part. If you don't have one, don't worry. We're going to be on page 204. And Miss Harrison and I will be working with you guys in small groups. But before we break out into 2 groups, I want to go over how we are going to measure and how we're going to have to use fractions to find our hand span, which we're going to talk a little bit about as well. So let me get this erased. So we're going to need to do a little survey, just like we saw in the video. And so the question is really going to be, what is your hand span? Oops. And in order to measure your hand span, you need to know how to use a ruler to the 1/2 and 1/4 inch. So I'm going to review that. This is something we have talked about, but it's been a while. So please pay attention to this before we start our measuring, because this is a good review.
Hey, it's Kaylee. In this lesson, we're going to learn to measure to the half and quarter inch. Let's go. Hey, it's Kaylee.
So I was going to stop it for a minute. Guys, we're just going to go to the half inch today. So I know in 3rd grade we do measure to the quarter inch, but I might stop the video because really for today's purposes, we are only going to need to measure to the half inch.
Measure to the half and quarter inch. Let's go. In our lesson so far, we've been measuring the lengths and heights of
Hey, Miss
objects.
Aubin,
Let's take a look at this red line.
I'm going to take Serene and go take her home so that I can go pick up my husband.
A perfect view of 7 inches. This means that the line is 7 inches. But what if it wasn't like 7 inches? What if instead our red line is somewhere between 7 inches and 8 inches? In this lesson, we're going to learn how to measure things that are between whole inches. Let's start with inches. I zoomed way in on our ruler here, so we only see the first 3 inches. Let's talk about what an inch is. This blue rectangle is 1 whole inch. In the United States, an inch is the smallest unit of measurement for length and height. But we know that there could be a rectangle that is smaller than 1 whole inch, like this red rectangle. If we want to measure something that is smaller than an inch, we have to divide the inch into parts. Let's use our blue rectangle to help us see. Remember, we measured our blue rectangle to be exactly 1 whole inch.
Charlie, Henrik, I need to see your eyes. Robert, I don't see you watching. And guys, you're going to be doing this, so I want to see everybody's eyes, whole body listening.
I don't
Some of-
have a ruler.
You don't need one. Katie, I need to see you, honey.
Now, if we draw a line right down the middle of our rectangle, what do we get? Well, now we have 2 rectangles that are each half an inch. So we see that we can divide an inch into 2 parts that each equal half an inch. Now, what if we draw a line right down the middle of both of the half rectangles? Now we have 4 rectangles. And using what we know about fractions, if we take one thing and divide it into 4 parts, each part is 1/4. This shows us that we can divide 1 whole inch into 4 parts, and each part will be 1/4, or 1/4 of an inch. Now let's take a look at the ruler again.
Okay.
Do you notice anything about the marks on the ruler? Yeah, these big lines here represent a whole inch. And then we see these 3 smaller lines in between. What do you think that this longer line in the middle represents?
It looks like you have a meeting.
Well, if we compare the distance from the taller middle line to the whole inch line, it appears to be right in the middle. So this is the half inch mark. And these shorter lines are heading halfway between the half inch marks. So they must be the quarter inch mark. Let's zoom in now between the 1 and 2 inch marks and do a quick fraction review. Remember, each of these distances is 1/4. So if we're going to count them, we would have 1/4, 2/4, 3/4, before we come to the next whole number. And we can simplify 2/4 to what? Yeah, that's right, a half. Now that we know how to divide inch into parts, let's measure the length of this green line. So if it starts here at the edge of the inch mark, and it goes 1/4, a half, 3/4 across the inch, this green line is 3/4 of an inch. out a benchmark. What is the length of this rectangle? It starts at 0 and it goes past the 3 full inch mark. By how much? Let's count. We have 3 1/4, 3 2/4, and 3 2/4 is the same as 3 1/2. So this rectangle is 3 1/2 inches long.
Okay.
How about this one?
I'm going to stop you there because we are going to go to the 1/4 inch, even though that is really good review for 3rd grade. But when we, and I'm going to put my document camera on, we are going to measure the length of our hand spans. And in our groups, so we're going to be in 2 groups, we're going to share our hand span measurement to create a tally chart, a frequency table, and a line plot. And so before you can do that, you need to know what it means to measure your hand span. Does anyone have schema on what hand span means? Reese, can I have whole body listening? That means your eyes are up here.
I do.
Sunny, I see you have your hand up. Go ahead, Sunny, can you unmute?
Like how long your hand is?
Not how long it is, but when you spread your fingers apart as far as possible, it's the distance between the tip of your thumb to the tip of your pinky. So I'm going to, here, can you guys see this? I am going to measure my hand span. Everybody show me your hand span. So this is not your hand span because you haven't stretched out your fingers. You have to spread them out as far as you can. So everyone spread your hands out. Let's see your hand span. Thank you, Max. Thank you, Lila. I see you, Reese. I see you. Sunny and Haley. Really spread it out wide. Robert, I don't see you there. I see you. Thank you. So when you do your hand span, you guys got it. You're going to use the ruler, and there's one on the computer that I'm going to show you, but some of you have your own. You want to take your thumb, the tip of your thumb, to the edge of that ruler and take the tip of your pinky to the other side there. Now, if I want to know what my hand span is in inches, if I go like this, it's going to change. So you got to make sure you spread it out as wide as you can. And I think that my hand span is 7 inches. Would you guys agree? Now let's pretend my hands go to about here, and this is my hand span. What would the measurement be, Katie, of my hand span? It's halfway between the 5 and the 6. What would we measure that as?
Five and a half inches.
Very good. So it should look like this. 5 is your whole number. 1/2 is a half. That's your fraction, 5 1/2 inches. Now, some of you are going to find that you're not exactly on a whole number or halfway through. You might find that you're at the 1/4 mark. For today's purposes, if you are, let's say your hand span is 7 1/4 inches. We're going to round you up to about 7. You can round up to about 7 1/2. We want to go to the 1/2 inch. So you'll either be, if you're between, let's say your hand span's really small, maybe you're between 4 and 5 inches. Maybe your hand span is really close to 5, but not quite, but super close. I want you to go ahead and round it up to 5. Just say it's about 5 inches. But if your hand span is just over 4, just a little over 4, you might say 4 inches. Or if it's 4 1/4, but not quite 4 1/2, we'll go ahead and round it up to 4 1/2. So we're not going to use the 1/4 or 3/4 inch mark today. We're just going to use the whole inch mark or the halfway mark for our hand span. So I want you to, when you measure your hand span, I want you to write the measurement in your math spiral. you will see on this assignment, I put an actual size of inch ruler as a link. You can click on that link and then you can put your hand up to that ruler and you will find your hand span. Okay? So that is what you will do if you do not have a ruler. You can use the one on the screen. So I'm going to give you guys a minute. Go ahead and measure your hand span. Write down how many inches your hand span is, and then we're going to get into our 2 breakout rooms, and Mrs. Harrison and I are going to collect data on the lengths of our hand spans and see which length occurs the most often. Like, what is the most common hand span? And we'll come back and we will share our data. So Mrs. Harrison, did you have any questions about what we're going to be doing?
Nope, I've been here, done that. We're good. I have
Okay.
the breakout rooms already for when you say go.
Okay, so we're going to go ahead and go in our breakout rooms. If you're still measuring, you can still do that, but please join your breakout room. Thank you, Mrs. Harrison.
You bet. Mrs. I'm in your breakout room number 2, just so you know.
Great, thank you. All right, guys, so I'm going to go ahead and start with Leo. Leo, did you get a chance to measure your hand span?
Yes,
What was the length?
about 7 inches.
Okay, 7 inches. So I'm gonna write it down in my tally chart. I'll show you guys in a minute. All right, Max, what is your length?
Trying to find a ruler, so just skip me.
Okay, I'll come back to you. You can use this one, Max, on the board, the one, you don't need to find one. You wanna use this one, Max? Just put your hand up to that real quick.
Mine is about 7 inches, I think. Yeah, actually, wait. Never mind. I can't really find this.
All right, I'm sharing my screen with you, so it should be on your screen.
Yeah, but
Put your either your pinky on your left hand on the edge of the ruler and see where your thumb ends up, or you can do it the other way with your right hand. Put your thumb at the edge of the ruler, see where your pinky ends up.
9.
You can't have 9 inches for your hand span because I'm 7, so it's gonna be more than that. Your hands aren't that large. Maybe a grown man. All right, we'll come back to you. Leo, I already got Leo. How about Charlie? What was your hand span?
My hand span was 6 inches.
6 inches. Okay. Let's do Lila.
So on the ruler, I couldn't get to it because it kept asking me like, are you Chromebook 11?
Okay, so I have mine up, so just use mine.
Okay.
So go back to Zoom and you'll see it.
7 inches.
Okay, Josh, what about you?
I was on the half mark of 6 and 7.
6.5 inches. Okay, thank you. Haley Calendar.
I was 6.5 inches.
Great. Reese, how about you?
I was 6.5.
Gabe.
I was 6.5.
All right. Astria.
I'm 5.5.
Check the chat.
Okay, Robert?
I am 6.5 inches.
Okay, couldn't hear you, Robert. I'll come back to you. Gavin?
6.5.
9.5.
There's no way. You couldn't
Yeah.
be. Try again. Put your fingers up to that ruler. You must not be on the edge. So Robert is
9 inches.
So honey, it's gonna be less than 7, okay? Cooper, you're 6.5. Robert is 6.5. Okay, so we're still waiting on Max and Gavin. Gavin, look at my ruler here. Put your hand up to it. There's no way your whole hand will cross over to that 9 from that 0. So show me that you're doing it. Thank you. You put 1. Okay, I'm going to show you again how to do it. You take your thumb would go on the edge. See, Gavin? You spread it out. And then you see where the other finger, either your pinky, depending on which hand you're using. Where it goes to. Okay, whose did I not get? Speak now or forever hold your peace.
You didn't get mine.
Who's that?
Max Fox.
Okay, Max. Yeah, I knew I was waiting on you. Did you figure it out?
No.
Gavin, did you figure it out?
10 inches.
All right. What Max and Gavin?
Robin,
Yes.
for the ruler that you show them, I measured my hand on it, and I think they have to go to big screen or it's gonna be way smaller than a normal ruler.
Oh, that could be what happened. Thank you, Haley. So you have it on a shrunken screen. Good thinking. So that's probably what happened, Max and Gavin. If your screen is small, it's not gonna be accurate. You have to go big screen. Good thinking. All right. Well, let's use the data we have. And Max, if you guys get to it quick, let me know. Go ahead and record this in your math workbook. We're going to do it as a tally chart. So this is what we came up with in our group. We have 7 inches, we have 2 tallies. 6 inches, we have 1 tally. 6.5 inches is 6 tallies. 5.5 inches is 1 tally. So Gavin or Max, were you able to enlarge the screen for the ruler, or do you want me to just go on without it? Gavin, you were? What did you get, honey?
Oh, I didn't get to measure my hand yet.
Okay, then I'm going to go on without you. We'll just use this data. Okay, so now to make that into a frequency table, you're going to write the same inches, but instead of doing tally marks, you're going to write the number for the tally marks. And when I count my tally marks for 6.5 inches, I can count by 5s and then add 1 more, so I get 6. 6 of you had a hand span of 6.5 inches. Wow. And then for 5.5 inches, we just had 1. Okay, so that is how you would make the data from a tally chart into a frequency table. It's really the same thing, except instead of tally marks, you put numbers. And then when we make our line plot, let's see, we have 1, 2, 3, 4, 5, 6 lengths. And we only came up with 4, so we would have to do 7 has to be the last one. 7. Oops, I'll just put a 7 here. So this would be 6.5. This would be 6, 5.5, 5, 4.5. Because that's going to show the range of inches that we had in our class. Once you label the inches at the bottom of your line plot, you're just going to put a dot for the number of students we had for each. Since nobody had a hand span of 4.5 inches, I'm not going to put any dots there. And nobody had a hand span of 5 inches. But how many dots would I put for 5.5 inches? What do you think, Max Fox? How many people had a hand span of 5.5 inches?
1.
1. So I want you to draw 1 dot above that. What about 6 inches? What do you think, Charlie? How many dots?
1.
Yeah, because only one person in our group had a hand span of 6. Oh, but 6.5, Leo. How many dots get to go above the 6.5 inch mark?
6.
Yep. 1, 2, 3, 4, 5, 6. Wow, goes all the way up on mine. And for 7 inches, Gavin?
2.
2. Okay, everybody hold up your line plot when you have it done. Let's see your work. Once it's done, hold it up for me. Cool, line plots. Good job. Are you able to answer the questions below? Like which length occurred the most often? Oh, good job, Leo. Looking good. Okay, good job, Charlie. Does anyone think they can answer which length was the most popular for us in our group?
6 1/2.
6.5 inches was the most popular. That occurred the most. 6.5 inches. I bet you guys can think of some good questions to ask as well using that data.
How many votes are there altogether?
Yeah, so we would know how many of us were in our group. We could ask if there are more people that have 7 inches or more people that have 6.5 inches. You could ask all kinds of questions. How many people had a hand span of 6 inches? And so forth. Okay, while you finish up, I am going to put us back into our main room. And we'll share with the other group and we'll see what they came up with. I'll see you guys in just a minute.
You're muted, Miss Alvin.
Miss Alvin, you're muted.
Okay, guys, I just wanted to check with Mrs. Harrison and make sure they were ready to share. And they didn't get quite as far as we did, but we'll see what their most popular handspan was.